A little bit of progress to report today. Let's see if I can get sharing going here. So this is what the top of my electronics board looks like at the moment. Was able to get the laptop fixed down, was able to install a e-stop switch. The wiring, interestingly enough, the wiring on the seat switch, the seat safety switch, which is what this looks like, actually has 4 prongs on it. And if you pull the tape back, you can see that there's, I'm confident that's a ground. And then there's a yellow with a black stripe and a yellow with a green stripe. And made notes someplace where those were going. The yellow with the black stripe. There's a yellow-black combination going into the ignition, and there's a yellow-green going into the PTO indicator. This particular wiring diagram is similar, but not mine, because they have wiring colors on here, and they're showing a yellow-white going into the seat. But anyway, it was useful to have a look at that. So what I did was this is the underside of the board. So this was the wire where the 3 wires came into. I just put a junction there and ran one over to a relay, and ran one up to the e-stop switch. It seems to work, but I do have issues that I'll mention. But anyway, so all of that was to give me a little bit of comfort to get out into the yard and do a little driving around. This is a little bit of driving around where I was just, well, I'll say it before, it's going to go from here down to here, and it's going to do that in about 8 seconds. I was just testing to see what the speed was, so I had measured that distance off and wanted to see what that sort of speed was, where the throttle and, or I'm sorry, where the transmission servo was at. So so anyway, that was and there's more steering going on there, but bottom line is I need more field testing to do steering. These are some of the things that I feel like I've gotten done. These are things to do. So tuning the steering is still definitely something to get done. I realized I'm not getting any data off of the tractor and into any sort of visualization tool like Plot Juggler. So I was going to take time to try to figure out how to get the data off of out of the TTGO board and into something that might look like a ROS message, so I could, analyze it. So progress, and that's sort of where I'm at. So the next step would be getting data off of the TTO board, so I could analyze it in something like Plot Juggler just to see where my steering is. Let's see, what else did I want to mention? Code is out on GitHub. This was in the steer vehicle function. I had put two potentiometers on the tractor itself because all of the testing that I was doing while I was sitting still and in the garage didn't seem to do very well. So I put two pots on the tractor and was adjusting those. And at the moment, I've got the KP set to 5.4 and D at 0, and that's what I was doing testing with most recently in the yard. So I was able to control it with that, but I just need to get more space and I think get visualization going so I can see how well the steering is making it to the target with my 50-foot path to test in. So that's sort of where I'm at. Not sort of, that is where I'm at.
So what I've been doing, I'm continuing to collect parts. Is my audio on? Yes, it is. So I'm continuing to collect parts. And I was saying before in one of the other meetings that I built this block that it's threaded there for a bolt for the axle. And then I drilled holes and put bearings inside. And one problem I had was I had a 4-inch bolt on the thing, and you can see that the thing slides back and forth. So I either have to put a spacer in there, either washers or cut a piece of pipe or something to stick in there. So what I did, I bought a shorter bolt. So this is the same type of thing, but now it's got a 3.5-inch bolt instead of a 4-inch bolt. So now there's no play in it anymore. So that took care of that problem. The other situation was this is how big the original block was, and I thought, well, that's too long, so I decided to make it smaller, make it shorter like this. And what I did was I took a block of plastic like that and put it on the table saw and cut off that much of the width of it, and that's what made the block shorter. So I basically built two new blocks like this. This is the newer, smaller, shorter block. And then when it's mounted, as they say, it looks like this. So it's, and the old one was that long, so you can sticks out closer to the wheel there. And that just made the whole thing a little bit shorter, and hopefully that's what I want it to do. Let's see anything else about that. And then I was looking at how is I'm going to actually steer it. So I've got, these are the original ball joints that this is what Sammy has on it right now to steer it. And then I just ordered some on Amazon that look like that. And I noticed these are more sloppy than I expected them to be. They're not real precise. They also stand up taller because it's got this little standoff thing here. And then the amount of threads here to adjust it. I noticed this one has more threads, and I got a lot more adjustment length on that. And this one's much more precise. It's just that I would have to have some kind of spacer to raise it up. And right here, there's just a nut on it right now. So if I use that nut to raise it up and then just put it through the plate and bolt it on like that, I can do that. So I can try either one of these type to see what it does. So on my thing here, I'm going to have to put a like bolt a plate on there that sticks up like this as my steering arm, and then this thing will then turn that, and it'll, however that works. If I pull it goes like this, push it goes like this. So I gotta get that made. I gotta get that thing put on there. So I think what I'll do in the middle is, instead of running one control rod all the way from the left to the right to give me my Ackerman, I think what I'm going to do is on the, say, here's one of those giant RC servos. This is the one that's for my transmission, but basically do it the same way, where I got this plate, and then I'll get a wider piece here. So I'll drill a hole here and drill a hole on the other side. And then in the center, these will come together in the center. So this will run one side, and then the other one will go like this to run the other side. So they both should be the same. They should be symmetrical at that point, I think. I haven't actually tried that, but I think that'll get rid of some of the issues of, trying to drive one side, and then the Ackerman makes the other side obviously different. So I think I'm just going to do that. Just put the two control rods right to the center instead of having one big long one that goes all the way across. Anything else? Anything else about that? Got that. The bolts. So then that thing I was showing a couple of times ago, this is the drivetrain from the green robot that I had. Oh, I see your video is switching back because you're not on mute. Now, anyway, this is the piece that went. This was on the green robot. I just unbolted it, and I didn't realize at the time. See, I can slide this back and forth on the shaft here to make it the width I want. So if I slide these together about that far apart, that'll give me like 12 inches between the left wheel and the right wheel, the center points of those, and then I can slide it out more if I want to. See, I'm limited by how close I can get them because of the back of the motor here. If I put them right up against each other like that, that's the most. Come on, that's the most narrow I can make it right there. But if I spread it out, originally it was way out like this. So I have 3.5 inches between the back. So if I bring it back, say 3 inches, this sure is awkward. So if I pull it about like that, then that I think that will give me the 12 inches between the two tires. But then the problem is when I started looking at it, those will slide around. But then I noticed that I had cut the shaft down. So this is a 1/2 inch rod out here, but this is either 7/16 or a metric. So somehow, I don't know if I did that on a lathe or how I did that. So I'm gonna have to figure out for my new shorter rod, how can I cut that shaft down so it fits on there. So that's gonna be another adventure trying to figure that out. So I might be able to spin it, if I put it in a drill. I've got a handheld 110 volt drill that I replaced the 3/8 inch chuck with a 1/2 inch chuck. So I've got, a piece of, so I can put my 1/2 inch rod into that drill to spin it. And at this end, I might be able to put, like, say, a bearing block here. Then with the thing spinning, then either just put a file on it and run it back and forth to cut it down, or take my angle grinder in from an angle and figure out how to get it to slide back and forth and just cut the shaft down. So I might try that and see what that does. So I say that might be another adventure to figure out how to do that. So I just simply have to cut this off at whatever from here out to about here is how I'm gonna that's about how long it's going to be, and then I have to cut the shaft down here and then cut the shaft down here so the wheels will slide onto it. So I'm still thinking that if I start with that back end and decide how wide do I want it to be, and that's based on a lot of things, like, say, if I'm going to put a laptop computer on. I didn't bring it down. I got those old Dell laptops. It's a Core 2 dual processor, and I think I measured 13.25 inches wide. And if I put the tires 12 inches on center, that adds about another inch. So it's about it. The outside of the tire is going to be about 13 inches wide, and the laptop's 13.25 inches wide. So that wouldn't be that oversized to put on there. So I might be able to put one of those laptops on there in the correct direction. If I turn it sideways, then I got lots of room, but then the cables are coming out the wrong side. So that's one issue. Then I need to look at it and say what I'm going to put on for sensors. So if I use one of the Asus Action Pro Live sensors, which is like a Microsoft Kinect, but it's smaller and it just runs off USB. It doesn't need an external power supply. So I can put one of those on there, and they should definitely work indoors. And then outdoors, I'd have to play with it and see, what kind of range can I get because the sunlight is going to try to wash out the infrared projection from that thing. So, but I can still put one of those on there. And I got the little the vacuum cleaner, little vacuum cleaner LiDAR. So I could put one of these on there, and that does a 360-degree scan. And again, I don't know how well it's going to work outside because it's not, it's not an industrial one. It was meant to work in your living room, so I don't know how well that's going to work. So I've just put various things on there. Just put a regular web camera on it, and so based on the size of those, that'll kind of give me an idea of how big I want the final thing to be. So it's just a matter of playing around with it and seeing what I can do. So basically, I'm going to set the width of the back, and once I get that, then go to the front. And so on the front, I just have to take these two pieces and say, if I want the center of the wheels to be 12 inches apart, then that leaves me in the middle. I measured this one, and it's three and a half inches from the center to here, and then I have to leave like a 1/4 inch between this and, see, like if this is my axle here, I have to leave about a 1/4 of an inch there, so I got room for it to turn. And I realize when I turn, it hits the corners. So if I take it and cut round this off and round that off, then it should be able to turn back and forth. So subtracting all that out, I think that says the axle in the center has to be like 5.5 inches wide. So it's going to be something like about that wide, and then this will be right on one end of it, and then on the other end of it will be the other one of those. So that would be that's why I have to set the width of it. And then I want to do like I did on Sammy, where I just built an extra bracket and put the RC servo right on there. So basically, it would be something like this, where I've made a frame on the axle and put the RC servo right on that. So maybe it actually go like this. I'll have to look at that here. When I get that far, put it on, maybe it's going to go on like that. And then, so anywhere along here, I could drill the holes for the connecting rods. And then and again, it'll just be one solid piece then when I'm done. So there'll just be one bolt that holds the whole front end assembly to the rest of the vehicle. So I'm still just playing around and looking at it. And I get so far that, oh, that's not going to work. So I have to look at something else. So, and I'm not working on it real hard. I'm just collecting parts. And every once in a while, I think about it enough that I think, no, I got to go try that right now. So I made these new blocks last night. I went out yesterday in the garage to distract me from cleaning stuff out. I took this block and put it on the table saw and cut the width of it down, and then cut the lengths of them this way, so I knew how big I wanted them. And then took it in the house and drilled and tapped this in, and then drilled these holes and pressed the bearings in. So that's what I got done. Other than just thinking about it, and I think just this morning I took this drive assembly off the green robot, so it's ready to start hacking on, and I'll have to decide what to do with that. So that's about all I got to say on that. I guess I haven't decided what to do for batteries on this thing, but I'm going to leave that to the last moment. Normally, that's the way I first start with. I say, how big are my wheels and motors, and then how big is the battery, and build everything around that. But at this point, I'll just grab some random batteries and put on when I get it ready to go. And for the moment, I just want to get it far enough that I could put power on the back wheels and run the steering, so I can drive it around, just to verify that driving the motors this way is going to work. So that's kind of where I'm at.
That looks great. It's real. There's a lot of design decisions to make when you're creating your own steering mechanism.
And I threw out most of the design considerations because I made it quite simple, and you can do all kinds of, there's caster and camber and kingpin angle, and you got your toe, and it just goes on and on. Then you got your Ackerman angle, and I cut it down to the point where the only thing I'm doing is controlling the Ackerman angle, and well, you can always adjust the toe, which is the, from the front, do they point in or point out like that, just by adjusting by adjusting these rods, you control that. So I can always control that. And other than that, my caster and camber are all 0 degrees, and the what they call kingpin angle, which, see, what you're supposed to do is you're supposed to have something that comes down, and the angle right here is supposed to be like that. It's supposed to point to the center of your tire down here. And right, mine just goes straight up and down. So it's actually going to rotate here. But what you really want is you want the thing to, you want it to actually rotate around on the ground at that point like that. But mine doesn't. Mine actually goes out. So it draws what draws an arc around here. Is it? Probably didn't make any sense. See right there, the wheel goes in this arc like that. What you really want it to turn, right around the wheel like this. But that's, I threw all that out and I got something that's close. I bet they built it the way that Sammy is built, so that I know that one works in steers. So that's where that sits right now. And that's all I got to say about that.
And it seems to me, back to my issue of getting data off of the microcontroller and into ROS. I think it's as simple as the serial. I'm writing a series of values to a serial port and then reading that on my laptop. Is that the way you would approach that?
You can either do it that way, or how are you connecting your ROS computer to your low level controller? You got an ESP32. Is it running like something like ROS serial, talking back and forth, or is it doing some other way to talk to that?
Well, at the moment I'm not. So this laptop at the moment doesn't have ROS. This laptop is really not performing any function when I'm driving around with the radio control unit. I'm just interacting with this antenna and directly interacting with this, which is directly connected to the motor controller that controls the steering and the servo, which you can't see. So
in that case, I would say if you've got USB that goes between your ESP32 board and your laptop, that gives you a serial connection. So yes, you could just do print statements and just print out whatever values you want on the laptop. Just say read it with whatever, either a terminal program, or write some software that says connect to that port and take the data and write it out to the hard drive or whatever. So if you're at the point where you're talking ROS between your laptop and your low level controller, then you can just build ROS messages and send them back at that point. But if you're not doing that at this point, yes, it's just easiest to just do a print statement and there's read that on the laptop and do whatever you want with it.
because I'm just pausing to think through that. I mean, if ROS navigation were running on this laptop, it would want at minimum what's the actual steer angle. And that's coming through a potentiometer that's connected here. So I guess at the just to start, I need to get that potentiometer angle off of that board and into this laptop so ROS can read it. Yeah. How did you do that on yours? Just the steer angle, the actual steer angle.
On mine, I do not read the steer angle. ROS is set up. The navigation says, here's a command velocity message. It says, I want you to go this speed forward and either this turn angle or this rotational velocity. And we beat that to death. But in your case, you're going to put out a steer angle and you're going to put out velocity. and it expects the low level board to do that. Now you can read back things from it. You can generate an odometry message. If you're reading your back wheels or you're reading speed or whatever, you could stick that into an odometry message and send that back up to ROS. But ROS doesn't need to know what your steering is set at. It just assumes that you know what you're doing. It says, I want you to drive over there. So it says, drive forward at this speed in this arc, and it expects the vehicle is going to do that. Now,
Yeah,
if you want to, you can generate any message you want. If you want to get all that extra information back, you can just stick, create a debug ROS message and stick all the values you want and send that back as a ROS message. And then you could then publish that and do whatever you want with it once it gets there. But for what you're doing right at the moment, if you forget it, since you don't have ROS running anyway, yes, just get that connection between your laptop and your board, and just in your code, just put out print statements and say print out like that stuff you're just showing on the screen. Basically, that I assume that is in your laptop already because you were displaying it. Yeah, that right there. I don't know. So that data is getting back. It's just a matter of what you want to do with it. So if you could say in your terminal right now, you could just say turn on logging, assuming your terminal program will let you do that, and then all these messages will go right to the hard drive. So as you go drive around, you'll have whatever it shows here would show up in a file on your disk.
Yeah, this is
Oh, that's part of that thing. Part
yeah,
of
it's
your
in the,
Visual Studio.
it's in the Visual Studio.
So look under well, let's see at the top where it says terminal. Is that the serial terminal, or is that just the that's probably just the screen that's showing? There may be some way, if you dig through here, there may be a way to say take that data in that terminal window and write it to the hard drive. So you go out to Google and say, how do I log serial data on Visual Studio, and see what they say there.
Yeah.
Otherwise, you can just start up a totally separate program, like let's see, are you running this? Is this running under Windows right now? Or is this running under Linux?
The laptop on the tractor is Linux, Ubuntu.
Okay, so just find you can find multiple terminal programs out there. So you just start up another terminal program, and those probably will have a way to just say turn on logging and put it out. So just write it out to a file so anything that comes in will get written to the file. And one of the programs called Minicom, but for some reason I can't ever get that to work. It's something about the way it interprets my keyboard or something, and I can't ever make that work. But there's several out there, terminal programs for Linux, that will let you type on it, and then whatever comes back shows up on the screen. And typically you can go to the menu and say, okay, now turn on disk logging. So whatever goes back and forth gets written to your hard drive. So that'd be one way to do that. Or you could probably just say cat USB 0 or whatever the port's called, and that will make it show up on the screen without using a terminal program. So then you could say, well, let's see, under what's it called under Linux? It's like TTY0. So if you say cat space TTY0, theoretically the data will just show up on the screen as the thing runs without running a terminal program. Now that has to do with whether or not you're talking to a real serial port, or I don't know, on your ESP32, I don't know if it's got like an FTDI converter, or if it's directly into the USB. If it's direct USB, you don't have to worry about baud rate. It just works. Is that connected to something right now?
It's all connected now.
So just type cat space. Well, first of all, what's the name of your serial port?
I don't remember. I was trying to remember what's the command to show what's connected.
Say like ls space /dev / asterisk. Try that. Just put it out. Yeah, just try that. Oh, that gives you all kinds of weird stuff. So it's mouse. But so put there's your serial ports there, and I guess we don't really know for sure which one you're connected to, but well, under Visual Studio, when you configured that to talk to it, does it Does it have a port name in there somewhere?
It figures it out itself.
So does it say on the screen somewhere what, does it tell you what it connected to?
Yeah, I'm sort of looking here.
I was just looking around on the screen to see if it told you, but I don't see anything there that says what it's connected to.
Yeah, if I do an upload as an example, I'm looking to see if it's in there.
It still says building and linking at the bottom, so apparently I haven't started the upload yet.
There, it's writing. Yeah, so it's, oh, there it is, TTY ACM 0.
Okay, so on your command line, you're going to want to say cat space /dev /tty acm 0. You're probably going to have to kill the software that's running on Visual Studio because it's going to conflict if you got both of them running. I don't know if you can say disconnect or you have to actually shut the program down.
Whenever I've tried to use Arduino, I've always had to shut it down.
TTY ACM 0, capital letters ACM 0. Just enter that, and what's that do? Well, there's this issue. It showed you one or two lines and then it stops, and I don't know why it doesn't continue on. I try it again. What's it do? There's something funny about the buffering there. So I guess that's going to be a problem. I don't know how to get around that. But if this worked, then see it's giving you the data that's normally coming in. It's just dumping it on the screen here. So as an extension to that, you could say, bring up that command line again, and then do space greater than, and give it a file name like just test or whatever you want to call it, and see what directory. It looks like you're in your home directory here. So enter that and see what that. And it looks like it immediately quit. So if you just say cat test.txt, you can see if anything's in there. And see, it puts some stuff in, but then it quits. And I don't know why it's doing that. I ran into this once before that's kind of what it does. And I don't know if that's something about the handshaking or that's how big a buffer it builds. So that would be a way to do it, but you got to figure out why is it terminated after 2 or 3 lines. But
Yeah,
you can see that would be a quick way to do it, though.
Yeah, I'll check Python and Google and
that isn't mentioning Python. That's another way to do it. Just write a Python program, say load up a serial port, connect to ACM, TTY ACM 0, and say read a line of data, and then say output it to a file. So you can just create your own little logging program. Or if you have something like that laying around already, just modify it to work with this.
Yeah, it seems to me I have it somewhere. I'll just have to find it. Yeah, I'm just trying to dust out the cobwebs and how to get that data out of there. Cool, thank you.
And then otherwise, if you just track down a random Linux terminal program, load that and start it up and say connect to TTY ACM 0 and see if it will continuously display. And if it will, then check to see if it has a logging feature and say log this to this disk file. So that'd be another way to do that.
Cool.
So back to your wiring, you were saying this is what your switch looks like, and you peeled back the wire and you saw that it had a loop back thing. I had theorized that that's what it was. You didn't actually have three green wires going in. You actually had that loop back. So now you tore the cable apart. I can see, yes, that is the way they built that. And I would say, yes, the green wires are ground. Now you can verify that by taking an ohm meter from the green wire to ground of your vehicle. But anytime you're going to use the ohm meter, you really should disconnect your battery, your main battery, so you don't blow stuff out. In fact, just working on stuff would be handy if you could just quickly disconnect the battery so you don't have so it's not connected there. Because again, if you short that just for an instant, you're gonna have fireworks. So be careful of that.
Yeah, I have this master switch. You tell me, do you, I mean, so this is the master switch, which should isolate the battery.
So that goes right to the battery then. Okay.
Yes.
It looks like you might have two wires hooked on the battery up there. Is that my imagination? It's hard to tell because it's cut off at the top, but
Yeah, there are very good eyes. I'll just zero in on it.
maybe that goes to your starter solenoid is where that other wire goes.
Um, I use that. There are two wires. There's only two wires. One's coming this way, and one is connected to Anderson pole connector to charge it.
Okay.
So, I don't
So
leave that in. I only use that periodically.
so yes, turning off that main power switch probably does isolate everything, so you don't have to disconnect anything. But anytime you're going to be measuring with an ohm meter, make sure you turn off all the power on your vehicle so you don't blow out your ohm meter.
Now, one of the issues that I have is this USB hub. You can see their power cable is there, but it's feeding 5 volts into that line. So even this is the ground and the power going to the USB hub. And
Okay.
when I turn this power off and isolate, power, my motor controller was still, LEDs were lit up. And I'm like, where the heck is that coming from? And it's coming from 5 volts that's going in there. Will a diode do the trick to only let power to this USB hub come in and not go out?
I don't think so. I assumed on a powered hub that if you have the cable plugged into the laptop, it's going to supply 5 volts to everything. But I thought when you plugged in that external power cord, the little coaxial plug, I thought that would disconnect the 5 volts coming from the laptop. In your case, apparently it's not doing that.
It's not. So,
And then back to this concept about if you're going to do testing, just unplug the cable from the laptop, and that way, with the main switch off and the laptop unplugged, then there shouldn't be anything putting power out. It's just you'll forget to plug it back in then when you go get to the next step. But
so anyway, that was a surprise.
so again, back to your seat switch. So you've got a green wire, which I assume is ground, and you can verify it's ground by in this case, if you're putting that right across a relay, you don't care where there's a going because your relay contacts are just like putting a switch in there. You're not actually tying it to any other power. But if you want to know if there's a ground or not, that's what you could do is disconnect your main power switch and unplug your laptop, then take your ohm meter and go from the green wire here to somewhere on your vehicle, like say the negative side of your battery, which is ground, and verify that is a direct connection there. And that'll tell you where that's going for future reference. You might want to know that. Now, since you got those two wires, did you hook up both of those wires to relays, or how did you end up doing that?
I did. I put them, oops, because I was effectively trying to make it like the switch was still there. um, I took both of the yellow wires and connected them together into this.
You may not want to do that. You might want to keep those as two separate circuits. In which case, if you're, I think you only need one of those. Probably one of them will kill everything. And you said the other one went to the PTO relay. So that's probably something about if the blade's engaged or not engaged. But I think the other one probably is just going to kill the engine directly. So I think you probably only need one of those two wires to be connected to anything. But they had those as two separate circuits for a reason. So don't just blatantly connect those together.
Well, here's the, I'm, I'm appreciative of the advice. Let me just, so there's a yellow black coming from the ignition and there's a yellow green going to the PTO. Those were in the seat switch. I was nervous about, interrupting that design because, effectively I've just put a different kind of switch on this end. But you're saying just stick with the ignition one.
I try them both. See if either one of those will indeed kill the engine if you ground that to the green wire. And if you get one that will do that all the time, regardless if your blade's on or not, that's probably what you want. Because I assume the other one is something about if your blade's engaged and you get off the seat, then it will kill it or something. I'm not sure why they have two wires there, but I think if you can get one of those to kill the engine, then just go with that one and leave the other wire hanging. Probably the PTO wires, leave it hanging.
Okay.
But by connecting those two together, you're violating whatever circuitry they had there. You're tying two things together on your vehicle that weren't necessarily intended to be tied together. And once you get off the seat, it ties all of those to ground. All of them get connected together. But in normal operation, you don't want those two. If you're sitting on the seat, you don't want those two connected together. So I'd say check them individually and see if one or the other will kill the engine like you want it to. And if it does, just go with that one and then just tape the other one off or something.
Okay.
Other comments, your laptop that you put on, does it have a solid state drive or is it got a regular, just a mechanical or rotary drive in the thing?
I think it still has a rotary drive. I think I bought a SSD, but I don't recall whether I put it on there or not.
Because the vibration of your vehicle may be hard on that hard drive. So just keep that in mind that may not, it may not hold up long term at least. And I don't know how quickly might damage it from the vibration. But if you put a solid state drive in, it won't care anymore. And I know if yours is built like mine, you just flip it over and take out two screws and open the back and you can get right to the hard drive and the memory and everything. As opposed to my new one, you got to pry the damn thing open. You got to go all the way around. And I'm worried I'm going to totally destroy it trying to do that. But the one I have that's like yours, I think that's fairly easy to get into it. And if you want to swap out the hard drive, you could.
Yeah, it's insanely easy. So yes, that's a good point. I did
Especially
use
if you already have a solid state drive you bought for it, that would be reasonable. Have you figured out how you could take your new solid state drive and copy your existing drive onto it so it'd be easy to just copy it and swap it out without having to reload everything from scratch? Sometimes when you buy a hard drive, it'll come with software to do that for you. And I've never done that. For 20 years ago, I probably did that, but the recent stuff, I haven't done that.
Trying to remember. I have, let's see, got some notes here somewhere. I use a thing called Clonezilla. Um, bear with me, I'm just pulling it up.
So whatever you do in the long run, at the moment, keep in mind that if this is going to be a problem, your hard drive might die at any moment. So keep stuff backed up as you make changes and stuff, just so you know, just so you have something you can go back to.
That is an awesome suggestion. That's part of the reason why I was putting my actual software out on GitHub um, as a backup, but that wouldn't be obviously a full backup of the machine. So Clonezilla, it's not, it's pretty clunky, but for a seasoned, you know, computer guy, you could use it without without issue. Just takes a little getting used to.
And my comment about backing up is just that, at the end of the day, take the files that you've been take the software that you're actually driving the thing with and just back that up somewhere and make sure you've got that. You don't necessarily have to back up the entire drive on a regular basis. It's just that when you go to swap out your hard drive, then you want to copy the whole thing over, and then at that point you shouldn't have the vibration problem anymore, I don't think.
Yeah, the one thing I'll mention about Clonezilla is um, I've always found it easier to make sure that because you're making an actual image to make sure the drives are the exact same size. So if you have a 250 megabyte or gigabyte drive, you're as the source, the destination needs to be 250 gigabytes too. It just makes it easier. Probably possible to mix them, but I've always found that to be an even bigger pain.
Yeah. I see you posted something in chat. Just a comment. Last week, I got no chat at all, so I had to recreate. I had to rebuild the chat from what by watching the video and creating links and stuff to do it. But for some reason, it didn't give me any chat last time.
Hmm.
And so this time, I just now that you put that there, I purposely saved it so I'll at least have it that way, and then I'll see if I get both methods. Then when we're done here. Just more of the stuff I was complaining about. Zoom keeps changing randomly, and I never know what it's going to do. So,
Yeah, I'm looking. I don't know why it would have. Let's see, what was the date?
and I don't think it's anything that we did. It's just simply that they chose not to save our chat either because when you start recording, I notice if you put stuff in the chat and then start recording, if it saves stuff, it only saves what was done during the recording. So there's probably some weird thing about the order there, and I hadn't thought about it at all. So it's just that when I went to do the video for last time, I noticed, hey, there's no chat there. So just just another data point to confuse the issue.
But what I cut and pasted in there was what looks like 1, 2, 3, 4 links that it saved on my side. I don't know if that's all of them, but it's 4 of them.
Okay.
Anyway,
I try to think if there's any other thing other. I see on to mount your laptop, you use blocks of wood instead of metal clips, but I guess that works just as well. Just something to keep it from sliding around. I see you do have bungee cords across the top to hold it down, so that it does. When it's driving around, could you tell was that staying fairly stable there, or was
it seemed to be. I mean, these are pretty stiff, and so yeah, I didn't see any movement whatsoever.
and
And I
and,
used
and
wood simply because I had it handy.
be careful about really stiff ones because it could damage your LCD screen that's under that lid right there. So just keep that in mind. Don't get real carried away with, like right now, if you'd shove a board under there to make them tighter, well, that's going to be putting pressure right on the back of the LCD. So
Yeah. We'll do it differently the next time, but that was just to try to get some field testing in.
And it actually looks like it's quite well set up there. So
Well, the only other you can't really see it from here. Let's zoom in. That would be a garbage bag over the top of it right now.
I was wondering if that's what that was. I assume that's in case it starts raining. Is that why you put it on
Yes.
there? Okay. I guess
So,
when you played that video, it jumped out in the middle. You did kind of a time warp, but there was it made a big jump. Does the video actually do that, or was just zoomed and decided to throw part of that up? It's about
no.
halfway over, and also it jumped about 10 feet ahead.
Um,
And it could just be that Zoom did that. So yeah, so start it right there and run it. And it's we still got the obvious point that it was driving along and it did get to where it's going. So but right before it, right about there, it jumped. So as I was watching this time, I see I could see that it was steering, and before I was thinking it just went from point A to point B in a straight line, but I see it now that I watched it again, I see that was some kind of steering going on there. So does that seem to be working out for you now? The steering, is it reasonable?
I mean it only has P, and I don't think it's very good. So that's why I need to try to get more data to try to tune it better. But I guess maybe the best way to do that would be to actually get ROS navigation going so I can consistently steer to one position and see how it's doing. I'm just thinking out loud here. Instead of me driving it around. It's like, what's the right testing protocol or tuning protocol to get the PID zeroed in on? I don't know. That's where I'm at.
So have we exhausted everything here?
I think you can turn off recording.
Okay.